Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous example, we computed the f-statistic using the sum of squares. In this video, we'll do the same test, but we'll use the r-square based formula. Keep in mind, both formulas will lead to exactly the same conclusion. So the null hypothesis will still be that all slope coefficients are equal to 0, and the alternative hypothesis that at least one slope coefficient is non-zero. So we're still doing a joint hypothesis test, but we're going to use different information so that we can use the other formula. And for that, I have taken again the usual skeleton. So this is the minimum information that you would have needed to do to run the f-test with the second formula. So right now we're going to use the r-squared. We're gonna still need the number of regressors. So given that the degrees of freedom of the model here is 3, it means that I very likely had a regression of y on x1, x2, x3. Here I would have had y, and here x1, x2, x3. I have number of observations here, so the sample size being 100. And I don't need any of the information on the sum of squares to do the rest of the computations. Based on the video that showed also the translation from the sum of squares formula into the r-square formula, we now know that the f statistic can be computed as r squared divided by k over 1 minus r squared divided by n minus k minus 1. Okay, so the n minus k minus 1, as usual, would have been in here. And we know that the total, given the number of observations here, is 100, which would have given us here 96 as usual. So the numbers here, k3 and n minus k minus 1, 96, means that, again, the f that test that we are, or the f value that we're getting here, is based on degrees of freedom 3 and 96. Now, keep in mind, the f-test here is not, we're not changing the meaning of it. We're still comparing explained variation per regressor to unexplained variation per degree of freedom. It's just that in this case, what is capturing this explained variation is the r-squared. And if you remember, the definition for the r-squared was like the percentage of the variation in the y variable explained by the x variables included in the model. To then unexplained variation, which obviously is whatever is left outside of that r-squared. So 1 minus r-squared. If we look at denominator and numerator separately, we can easily compute in here that the r-squared divided by k is the 0.4 divided by 3, which is approximately 0.133. And then we have in the denominator 1 minus r squared, which would have been simply 0.6, given that is 1 minus 0.4, divided by n minus k minus 1, which is the 96, and that's going to give us approximately a number that is quite small, 0.00625. So now that you have both the numerator and the denominator in here, you can do the computations, and no surprise, you're going to see that the f value here, it's still that 21.3 that we found in the previous video. Okay. Now, we can compare this f statistic to the critical value from the f table, which we already had as 2.696 for the 5%, and we took 100 as the approximation because we didn't have the 96 exactly. This number very clearly smaller than the f star that we have here of 21.3, which made us come to the conclusion that we can reject the null hypothesis. Because this f statistic is so large that it would have been very deep into this right tail. So it would have been somewhere very far away there. Keep in mind, rejecting again the null hypothesis means only that the regressors taken together, they improve the model compared to you using simply the mean of the y variable by itself. So it doesn't mean that the coefficients are significant individually or that you have found a model that is causal. So keep that discipline, keep that thought process always with you. The R squared based and the sum of square based formulas should give you the same F statistic. They are just two ways of packaging basically the same comparisons. Now that you've seen both the F statistic formulas and the worked examples, you're ready for the final step, which is using the F tests to compare models directly. So stay tuned and I'll see you in the next video.